Yes, because that's what the competition is. Okay, so we're going to talk about area between curves. I have 3 examples for you. Are you ready? Okay, well, I'm giving you that this is a loop, right? So, obviously this is a loop. Let's just get the shape. When we plug in 0, we get, when we plug in pi over 2, pi, 2, and 3 pi over 2 would be negative 2. Okay. So when I mean find the area between the loops, I'm talking about this area right here.
Is this the shape that a candle flame leaves?
I don't know.
Kind of looks like one.
Okay, what's going to be important for us to know before we get started?
You have to know the intersection points.
Okay, of the, okay, so like right here?
Yeah.
Okay, and it's at the pole, right?
Yeah.
So since it's intersecting at the pole, we just need to find its zeros. Okay, there's 2 zeros we got to find. So let's do that. This is convenient. Sine of theta is negative 1/2. Where are the 2 places?
Seven pi over 6 and 11.
Third and fourth quadrant, right? It looks like a pie with 3 legs. We already talked about occupying here, right?
You ever done a fighter?
Yeah.
What?
You ever done a fighter?
Oh, what?
Fighter?
No. All right. What are we gonna do?
Somehow we left
You
the
can make
area.
divided in half.
Okay, so dividing it in half is good. Since we start right here, like this is 0, and then we go around and we come back to 2 pi. So I would split it into this half, right? Now, you keep talking about 2 integrals, right? If I start finding area here at pi over 2, what's happening?
It includes.
We're coloring through that loop, right?
Then we'll subtract that, half of that thing, and then.
So undo. There's my undo. So from pi over 2 until where? I'm going to go from pi over 2 until
7 pi over 6.
and then we're going to have to subtract out from 7 pi over 6 until
Yeah, it wouldn't it be?
so if we want to like double this, we would want to pick 3 pi over 2. And then we could double all of it.
What's 11 times? That's 0, where is that?
So, okay, so in green, this would be 7 pi over 6
Okay.
to 3 pi over 2.
Okay.
So it would be finding that guy, which is symmetrical to the other half, right? So essentially, this is going to look kind of funny, but you'll get the point. We are finding the red area, subtracting out the green area, and then doubling it,
Yeah.
right?
Makes sense.
Okay? We do need to do this by hand.
Why can't we use our calculators? That was so good. It builds
Okay, so 2 plus 4 sine of theta the quantity squared. We know that that's going to be 4 plus 16 sine theta plus 16 sine squared theta. What? No? Yes?
Yeah.
I'm just saying something. I'm not. Mine wasn't gonna fit on there. I would not write that on the AP test.
What if we do the little like
Challenge
quotation marks in? Like, would that work?
You need to save time.
Do they accept that? If you're running out of time and like you
I
don't
would.
have.
I would try it. Okay. Dun, dun, dun.
Can we,
Another one. Five. Dun.
Close.
Okay. 16 sine squared theta. What do we have to change it to? Okay. Okay, so 1/2 minus 1/2 cosine of 2 theta multiplied by 16, so 8 minus 8 cosine of 2 theta. Four plus 8 is 12.
I have a question.
Yeah?
Never mind. Never mind. Keep going.
Better? That's a theta where my markers draw a little wonky. We're all capable of cutting the numbers. Oh, do you want to go through it?
Yes.
I care more about getting through the setup of these. Okay, once we recall what to do with sine squared and cosine squared, those are going to be our biggest obstacles.
They're pretty easy.
Okay? Now it's just a matter of can we set it up correctly. Okay? Yep.
What is ditto?
Ditto, same as before. So ditto
Touche.
is in relationship to that. So if you said I'm hungry and I said ditto, that means I'm also hungry.
Peter, it's literally like it was a thing when like
They didn't
my
teach me
parents
that in this
were
campus.
like my
Yes,
dad did it a lot.
They didn't teach you to do that in this
Second of 3.
Oh, man.
Just because I have a really big picture, you're freaking out?
Yes.
Well, you can just
I
multiply,
don't
that's understand, you can just multiply it by 4.
You can just multiply by 32 if you wanted to.
What about Dilly Dilly?
Yeah, do you know what that means?
I mean, it's just like a cheers.
Actually, no, you can multiply it by,
So it looked it up,
We're not
instead
working
it
on
was
problem yet.
It means the
you can multiply it.
or the light bulb.
Huh.
Light bulb, I think.
It's a flower.
So do you have to find intersecting?
We will have to find intersection points. I'm more worried about you writing down the problem right now. So you know the plan.
Yep.
Oh, do you want to start at 4:30 or not? 'Cause I'm gonna vote.
Are we gonna have another,
Well, it depends on if your job is to hand out for handing that or not.
We're handing stuff out of the door.
Okay. We'll go first.
Are we
We'll
gonna-
check with Daniel first.
Okay, he told us 5.
He did.
Then go with Daniel. All right. Now, we need intersection points, right?
yeah.
So we need to know where 4 sine of 2 theta equals 2. Ah, well, that's nice. This is where the sine of 2 theta is 1/2. Now, how many intersection points do we have? 8. How many do we maybe need? I would say at most 2. And so the first 2 places sine is 1/2. 5 or 6.
And
5, 5 or 6. So our first 2 intersection points are pi over 12 and 5 pi over 12. That's right here.
And then we
Now, that would be the case now. When we find area between 2 curves in rectangular mode, we're looking for highest minus lowest. Do you agree?
yes.
So total.
Okay. Okay.
We wanna do.
Wait.
Basically, we're not going to subtract anything in an integral. We need to figure out how many integrals we need. It's not just one integral. If we start here at 0, we start drawing area along what? The pedal. So from 0,
The pi over 12.
from 0 to pi over 12, we are finding area on the pedal.
Why don't we find areas?
I guess it doesn't matter.
we're at its peak right now.
Okay.
We'll just look at the shape.
Then, once we hit pi over 12, from the pole, we start drawing area inside of the circle.
So we need to do.
Right? It's not that bad. So, from pi over 12 to 5 pi over 12, we're finding area of 2 squared. Or 2, right? Then, once we're at 5 pi over 12, we continue until we finish out that pedal.
Wait, why is it done?
Do you even need to add that one, or could you just multiply the front one by?
Okay, great question. So we're gonna quadruple this because it happens 4 times. Austin just asked, do we have to do this calculation right here, or can we double this one?
Double.
You could double that one, okay? What I might do is I might write this all out, but only do these 2 calculations, and I just know that this was the same. Okay, I don't care how you do it, but I want you to visually see what's happening with our area. We're not like subtracting necessarily, is we're just figuring out where our area is along our curve. What? Just talking through it?
Yeah.
Okay. That's good. We have one more, well, ish, one more example.
So let's just say, like, on the test, would this be a calculator problem?
This might be one where I ask you to set it up.
If not, okay.
I like those.
Yeah.
So then you set it up wrong. You just-
Yep.
Yeah.
Nowhere.
Where's the pirate flower? Pirate flower.
What?
I don't know where the last.
We said these people to each other.
Right.
This pi over 2 right here, buddy,
Yeah.
it comes from,
It is a pi over 2, dude.
yeah, this is a pi over 2 because we're doing this area and then we get to the point where that pedal is done. And that pedal goes from 0 to pi over 2.
We don't do that one.
Okay.
Set it up.
All right, I want the common interior. That's another way you'll hear it described. Common interior of these two. What are these two things?
They are cardioids.
Oh, see, it's like a.
Cardioids. One is going to the right. One is going. What?
Areas in the middle.
I think that word is not allowed in my classroom. Not allowed in my classroom. Don't like the SC word.
Let's try to get some.
Right, Jake?
All right. What do we do? Well, what do we need to do?
We need to find a part of this circle.
Would it help if I did one of them in another color?
You find the
So
area
let me go
like
to
the
the,
hat.
Yes, we need to find the intersection.
Okay, don't you think we need these 2 points right here? Okay, so when is 2 plus 2 cosine theta equal to 2 minus 2 cosine theta? Isn't that just cosine theta equals negative cosine theta?
Whoa. 0.
That is intense. Some of us could figure that out,
Yeah.
right? If we really thought about it. Some of us like the algebra to prove it. Not Grayson. Okay, so what can we do? Like this, right
Yeah.
here?
Yeah, multiplied by 4. You couldn't do that if, like, they were different,
Okay,
but
but we have some symmetry, right? Since these are 2 minus 2 cosine and 2 plus 2 cosine theta, this green
Can I just do
Semi-
that based on one of
cardioid hump is the same as this right here, right? I don't know, it's not like it's a lizard thing. What?
and it's the one above too.
Yeah, those are all the same. So we can just say 4 times. All right, which one is that?
negative.
Yep.
We could do either.
Yeah.
Limits of integration.
Or we just do this. That'll be from, yeah.
So 0 to power 2.
can you do like that?
Yeah. As long as you don't do 0 to to 2 pi.
Okay.
No, it's not.
Stop.
Okay.